For two sets A and B, the number of elements in the Cartesian product of A and B, that's equals to 6. Also, 3 of the elements of the Cartesian product of A and B are provided to us. They are 3 ordered pairs. Using this information, we need to determine the Cartesian product of A and B and the Cartesian product of B and A. Okay, let us begin. Now, let's try to understand the problem first. So clearly it's given here that the total number of elements in the Cartesian product of A and B, that's equals to 6. However, we know for a fact that the total number of elements in the Cartesian product of A and B is simply given by take the total number of elements in the set A and multiply it to the total number of elements in the set B. Now, since this is equals to 6, so there are two possibilities. Either number of elements in set A, that could be 2, and number of elements in set B, that's equals to 3, such that their product gives us 6 elements. Or the other possibility is that the number of elements in the set A, that's equals to 3, and the number of elements in the set B equals to 2. So before even calculating, we know how much elements could be present in each of the two sets. Okay, now it's given here that the ordered pair 1, 4, this particular is an element of the Cartesian product of the set A and B. So 1, 4 belongs to the Cartesian product of A and B. What does it tell us? It tells us that 1, the first element of the ordered pair 1 is going to belong to the first set, that is A, and the second element of the ordered pair, which is 4, is going to belong to the second set, that is B. Fine. The next ordered pair that's given to us as 2, 6, which is going to belong to the Cartesian product of A and B. This simply tells us that 2 is going to belong to the first set A, and 6 is going to belong to the second set, that is B. And then we have 3, 6. So 3, 6 belongs to the set A and B, which means that we have 3 belonging to the set A and we have 6 belonging to the set B. Now, if we combine these three results, we say that set A consists of 3 elements, 1, 2, and 3, whereas B consists of 2 elements, 4 and 6. So this is going to be the only possibility. This is not the possibility. So that means now we can define the set A. So now our set A is going to be the set containing 3 elements. So those elements are 1, 2, and 3. And then we have the set B. So set B contains 2 elements. Those are 4 and 6. So now that we have the two sets A and B, we can easily obtain the Cartesian product of A and B. So A contains the elements 1, 2, 3. We are going to take the Cartesian product with the elements B, which is 4 and 6, which are 4 and 6. So now we'll be forming the ordered pair. We'll consider the first element of the set A, which is 1, and form an ordered pair with each of the 2 elements of the set B. So we have 1, 4 and 1, 6. Next, we are going to consider the second element of the set A, which is 2. We're going to form the ordered pair with 4 and 6. So we have 2, 4 and 2, 6. And then we have 3, 4 and 3, 6. Fine. So this is the set A, the Cartesian product of the set A and B that contains 6 elements here. Fine. And once we can find out the Cartesian product of A and B, we can find out the Cartesian product of B and A. All we have to do is first consider the set B containing the elements 4 and 6, and then find its Cartesian product with the set A containing the 3 elements 1, 2, and 3. So I'll leave that as an exercise for you to try out. However, what we can do, we can take the Cartesian product of A and B. What we can do here is we can flip the position of each of the elements in the ordered pair. That means for the first ordered pair 1, 4, we're going to flip the position of the elements to get 4, 1. Then we have 6, 1. We will have 4, 2. Next we have 6, 2. Next we have 4, 3. And then we have 6, 3. So you can compare it with the regular way, the way which we use to find out the Cartesian product of A and B, and you will see that this is the same, these are the same 6 elements that we'll obtain. Okay,